All right, we're actually going to do lesson 7.1 and 7.2 today. I believe I gave all of you the notes, so you should have this and shouldn't need to copy very much down except for the definitions. So theorem 7.1, the Pythagorean theorem. This is nothing new. We've done this from the beginning, right? Usually we say a squared plus b squared equals c squared, but this also works too, right? The same equation, a squared plus b squared equals c squared. Okay, easy peasy. A Pythagorean triple is something that you should know. That is a set of three positive integers that satisfies the Pythagorean theorem. Okay, an integer, remember, is not a decimal. So when we say three positive integers, we're actually talking about natural numbers. Okay, so numbers that you can see in nature. So 1 to infinity, positive infinity. Okay. All right, so to find the value of x, here this is the hypotenuse. So x squared is equal to, okay, using, I'm sorry, typically we always do a squared plus b squared equals c squared, but I'm going to set it up this way because when we talk about 7.2, you'll see why. So it really doesn't matter which leg is which. 15 squared plus 8 squared, that equals x squared. And then we just need to solve, right? 225 plus 64, that equals x squared. Add them together, and I get 289 equals x squared. Take the square. Take the square root of both sides. That's how we unsquare something. Okay? So x is equal to 17. This is a Pythagorean triple. All of the sides of this right triangle are positive integers. Okay? Be really careful because sometimes the missing side isn't always the hypotenuse. So here in number 2, C, right? And then I'll just make this A, and this will be B. So C squared, 20 squared, equals A squared plus B squared, or 15 squared plus X squared. 20 squared gives me 400, equals 225 plus plus X squared, right? Now we have to subtract 225 to get x squared by itself. And that's going to give me 175, I believe, equals x squared. Then again, we need to take the square root of both sides. I take the square root of 175 and I get a decimal. That means it's not a perfect square. So we could break it down, right? I know that 25 is in there, right? So 175 equals the square root of 25 times 7, or the square root of 7, I'm sorry. And the square root of 25 is 5, so 5 root 7 is what x equals. That is not a positive integer, okay? So this is not a triple. So x equals 5 root 7, and this is not a triple. All right, cool beans, cool beans. So now you know the deal, right? If you get a decimal where you don't have a perfect square, it's not a Pythagorean triple. All right, I know how much you all love word problems, and I think it's because you've been able to avoid doing them, so you're not very confident. But I'm not going to avoid them. We're going to do them together, and maybe we need to read it multiple times to understand it. Okay, so a 16-foot ladder rests against the side of a house. And the base of the ladder is 4 feet away. How high above the ground is the top of the ladder? So I have this little triangle here, okay? This triangle represents this situation. A 16-foot ladder rests against the side of a house. Well, if you've ever used a ladder before, you know we don't set them up vertically along the house. We would set them up like here. So this hypotenuse is actually my ladder. Okay? And then it said the ladder was 4 feet away. So we can first mark this as 16 feet. That's 16 feet. The ladder is 4 feet away from the base. So that's this distance right here. 4 feet. We do not know how high above the ground, right? So we want to know what is the length of this side. How high is that? So that's going to be our x. That's our unknown. Okay? In questions like these, and it'll be on your homework too, it is okay to round to the nearest tenth or even hundredth. Like the more farther out you round in the decimal, the more accurate your answer is. I won't ask for you to put this in radical form, okay, if it just so happens to be so. So let's set this up. I'm still going to put my hypotenuse first. So 16 squared is equal to 4 squared plus x squared. All right, and 16 squared is 256. 16 plus x squared. We subtract the 16 here, and I get 240. That's correct? Oh my goodness, I'm zeroing crazy. Sorry about that. That's pretty huge. Oh my gosh. Oh, technology, so fun. All right. 240 equals x squared. I'm going to go ahead and see, is it a perfect square? And if it ain't, we're going to round to the nearest tenth. So let's take the square root of 240. So we we take the square root, and I get a decimal. So I get that x is about, and if it's not totally equal to, do like a squiggly equal sign, and it's 15.49. I'll round to the nearest hundredth. Hundredth is 2 places to the right, That's the hundredth place, the 9. So that's how tall the ladder is, and let's not forget our units, okay? So the height of the ladder is actually 15.5 feet above the ground. So up here, that's this vertical distance here, that's 15.49 feet. All right, find the area of the triangle. Let us recap on the formula for area of a triangle. Area equals 1/2 times the base times the height. Okay, so we're going to work with this equation here. Area equals 1/2 times the base. Well, the base is 20. But I need to know what the height is. Okay, so this vertical line here is the altitude. It also does separate the base here, so it is a median as well. Here, just for the sake of this assignment, what we're going to do, and this is actually like the activity that I had you guys do on the very first day of school. I don't know if you remember doing this. Finding the Pythagorean theorem of an isosceles triangle, okay? So what we're going to do, I'm going to split this triangle in half. I'm going to try to copy it as best I can. You know, I'm not the best at art. Right, this is going to be 26. This is my height, which is x. And now I'm just going to be taking half of the base here. So that's going to be 10. So I need to find out the height of this triangle so I can plug it into this formula here. So again, we have a right triangle, okay? So I have the hypotenuse is 26, so 26 squared equals 10 squared plus x squared. Well, 26 squared is 676. 100, oh, 10 squared is 100 plus x squared, right? We subtract 100 from both sides, we get 576 equals x squared. And get out your fancy little calculators and take the square root of 576. And we get 24. Cool. So x is equal to 24, or the height of this triangle is 24 feet. So now I can plug in 24 for the height. All right? So when we plug this into your calculator, or you go ahead and multiply, you don't even need a calculator for this, because half of 20 is 10, and 10 times 24 is 240. The biggest thing to remember is when you're talking about area, it's always units squared. Okay, area is always units squared. So that's all there is to that. That was like cake. All right, so now comes lesson 7.2. We're going to use the converse of the Pythagorean theorem, which is why we were writing the Pythagorean theorem in reverse. Converse, that's what that means. So it says, if the square of the lengths of the longest side of a triangle, right, the longest side is always the hypotenuse. So if it is equal to the sum of the other lengths, of the other two sides' lengths squared. I'm trying to write and read it, sometimes not working out. So let me start again. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, right? It must be equal. Then it is a right triangle. If it's equal, it makes it right. And you're like, duh, it's the Pythagorean theorem. Here's something we're going to expand upon, right? Let's look at the next example. Well, now we don't have a right angle. I don't know that this is a right triangle. So I'm still going to use the converse Pythagorean theorem. If we square the longest side here, C will be the longest side again. And then if the longest side is less than, that's why we have to put C first. So if C squared is less than A squared plus B squared, then it is an acute triangle. This makes it acute, right? It's a small, acute, less than. It's an acute triangle. And last but not least, if we square the longest side here, again, it's going to be C. If it is greater than, if it's bigger than the sum of the other two sides squared, then this triangle is obtuse. Okay, it's really important that you start with C squared, because if you rewrite this and then in your mind you're thinking greater than obtuse, less than acute, and you rewrite this, now you don't necessarily need to write this down, but I'm just going to show you, if you use the Pythagorean theorem the other way, you might read this as less than, and you might think, oh, it's acute, but it's not. This is the same, I rewrote the same inequality, so I just don't want you to be confused about that. So if C squared is greater than A squared plus B squared is acute. C squared is less than A squared plus B squared is acute. And if it's equal, it's right, if you're in that. All right, so first off, let's not forget what defines a triangle, okay? If the two sides, the two smaller sides added together are greater, or they must be greater than the third side in order to even be a triangle. So you always want to check if it's a triangle. Check to see if it is even. a triangle. Oh my gosh, if I could spell all together. And remember, that would be A plus B must be greater than C. Okay, and all these numbers, just for the sake of this activity, will be in ABC order. 3 plus 6, is that bigger than 7? Yeah, 9's bigger than 7. Now let's check to see if it is right, acute, or obtuse. So I'm going to take 7 squared. Like I said, they're in ABC order. So this is A, this is B, and this is C. So 7 squared, I'm just going to put a line here because I don't know what it is yet. I'm just leaving it there because I'm not going to say it's equal to because I don't know yet. And then we further simplify that and we get 49 here. Still don't know. 9 plus 16. Well, 9 plus 16 is 25. So 49 is greater than 25. That makes this triangle obtuse. Okay, so with that being said, go ahead and try 2, 3, 4. Pause the video and practice to see if you are okay with this concept. First, check if it's a triangle. Then you want to compare c squared to a squared plus b squared. All right. Okay, so first, number 2 was not even a triangle. So if it's not even a triangle, don't even worry about it. It's not even worth your time. Okay, number 3 turned out to be a triangle, so I went ahead and compared c squared to a squared plus b squared, and I got that it was acute. The c squared was less than. Number 14, c squared was equal to a squared plus b squared, so that was right. So if you got the same answers, hooray! If not, oh no, keep trying. Don't give up. All right, do have another example on this page. I didn't see it until I was working on those answer keys. So we can do this together. 6 plus 9, is that bigger than 12? Well, yeah, 6 plus 9 is 15. Oh my gosh. See what I get for trying to write and talk at the same time? Is that bigger than 12? 15 is bigger than 12, so I can move forward. Check that box. Now, 12 squared plus 6. Oh, goodness gracious. No. Thought I was in a groove. Not equals. We don't know what it is. We're not adding, so I'm going to put that little line there. 6 squared plus 9 squared. 12 squared, 144. 6 squared is 36. 9 squared is 81. And I add 36 plus 81. I get 117. 144 is greater than 117. So this triangle is obtuse. All right, so these were kind of easy ones because they were all like integers. Let's just look here. So actually what I want you to do is just go ahead and pause. Just do 6 and 7. Leave 8 and 9, and then I think I have another one on the other side. We'll talk about this in a second. But you pause the video and do 6 and 7 just to see if you've got the hang of it now. Okay, number 6 was actually acute, and number 7 was also not a triangle. 8 plus 13 is 21, and that is not bigger than 22. So no need to go any farther. So in order to determine if this is a triangle, what I want you to do is we're just going to round for the sake of just checking to see if it's a triangle. So put in your calculator 3 root 7, and we get 7.94. Let's just say 7.9. So for the sake of this, just to check if it's a triangle, we're going to do that. We're not going to do that when we determine if it's acute, right, or obtuse. So 7.9 plus 9, is that greater than 11? Well, it's going to be, what, 16.9? Yes, that is greater than 11, so it's a triangle. Now we're going to go ahead and plug in the numbers that are given to us. So C is 11. I'm comparing that to a squared plus b squared. Okay. Remember from, well, I don't know if you guys watched the video or not, but when you square a radical, especially if it has an exponent out front, you're going to, a coefficient out front, you're going to square that 3, and that's going to give you 9. And when you square the 3, they get 9. When you square a radical, you just free that number outside of the radical and then multiply it by whatever number's out front. So now 9 times 7 is actually 63. That is 3 root 7 squared. You can also use your calculator, use parentheses, 3 root 7. Hold on now, my parentheses not opening. 3 root 7 squared is 63. Okay, good. And then we're going to add that to 81. And we know that 11 squared is 121. Well, we should know that. So 63 plus 81 is 144. So now I have 121 is less than 144. This triangle is also a cube. Okay, now I have to find the decimal twice just to check to see if it's a triangle. So 8 root 6 is 19.6. And 8 root 15 is actually it's going to be 31 about. Okay, so I want to know if 19.6, if I add 24, is that greater than 31? So 19.6 plus 24 is 44.6. That's definitely greater than 31. Cool. Now we're going to plug in the original numbers to the converse Pythagorean theorem to see if, in fact, it is a cube, obtuse, or right. So, use parentheses if you're just using your calculator. 8 root 15 squared, right, that's my c squared. We're comparing a squared, which is 8 root 6, squared plus 24 squared. All right? So remember, when you're squaring a radical with a coefficient, you square that number, right? 8 squared gives us 64, and then you free the radical. So 64 times 15. And that's going to give you the same thing you would get if you put it in the calculator. 64 times 15, 960. And then let's go ahead and do parentheses 8 root 6, close parentheses, square it. That gives me 384 plus 24 is 408. Is that right? I feel like that's not right. Oh, plus 24 squared, you silly goose. Good grief, Charlie Brown. Okay, so the right side equals the left side. So they're both 960. So what does that mean? That means it's a right triangle. So lesson learned. Don't forget to square all the numbers so you get the right answer. All right, like I said, I have another example on the other page. And, if I'm ever going too fast, you can always pause and copy this stuff down. Ah, I was just kidding. I thought I had another example. I guess I don't. Well, ladies and gentlemen, that's the end of it. Here's assignment number 30. Like I said, it was 7.1 and 7.2. There are not that many problems here, and you should be able to do this no problemo. So make sure you turn this in the Dropbox, and I will see you guys tomorrow. Have a great day. Bye.